We'll learn depth-first search in this video. The DFS algorithm is a recursive algorithm that uses the idea of backtracking. The word backtrack means when you are moving forward and if there are no more nodes in the current path, you move backward on the same path to find nodes to traverse. The recursive nature of DFS can be implemented using stacks. Let's see an example. This is a tree, and we will use DFS to traverse this tree. First, 1 is the head node, so we start from 1, and then we visit 2, and then we visit 4. We can see now in this path there is no more nodes, so we will go back to 2, visit 5. And now under 2 there is no more nodes to visit, so we go back to 1 to visit 3. Now all the nodes are visited. That's the DFS. And how to use a stack to implement DFS? Let's see a demo. So here is a graph, and we will use stack to track the nodes. So first, A is the head node, and we will visit A and add A to the stack. We will process AC. From A, we find the path AC, and we will call that depth search on C. And then we mark node C, then we add C to the stack. And from C, we can see its neighbor nodes. A is already marked, so we will process C to B. And we will call DFS on B, and we mark B and put B to the stack. And now from B, we can see C is already visited, so we will process B to F, and we will call DFS on F, mark node F and put F to the stack. From F, we can see the B and C is already visited, so we will process F and D, and call DFS on D. We will mark D and put D to the stack. Now we can see from D, all its neighbor nodes C and F are visited. C are visited, F is visited, so we will pop D from the stack. After popping D, we can see from stack we will get F. So we will process F, and FE is not processed, so we will process FE. Call depth search on E, and mark node E and put E to the stack. Now we can see from E, all its neighbor nodes are visited, so we will pop E, then pop F, then pop B, then pop C, and then at last we pop A. Now the stack is empty and the traversal is finished. Let's practice DFS. We can see given a graph consisting of n nodes and m edges, the nodes in this graph is from 1 to n. And the graph can consist of self-loops or cycles. And we are given a head node, and we will from this head node to traverse this graph. Now you need to find and print the number of nodes that are unreachable from this head node. We can see, let's see the input format. The first line consists of two integers n and m, and And the next m lines consists of two integers a and b, represent a edge from a to b. And the last line is an integer point to the head node. This is the sample input. We can see the first row is n is 10, so there are 10 nodes. And the second 10 is the number of edges, so there are 10 edges. And the next 10 rows are the edges from node A to B. The last line is one number. This means the head node is 2. So now let's start coding. Scanner, new scanner to read the input. First is the number of nodes, and then is the number of edges. And the following m lines is the edges. So the first is, let's call it A, and then B. So how to represent a graph? Here we can use a map. Integer, the first integer is the node, and the map value is a list of integer to represent the connected nodes. So let's put the node and its connected node to this graph. First, we need to initialize the array. Then we'll put for A, we will add B to its connecting node. And for B, we will add A to its connected node. Now the graph is constructed. And we have the last input is the head node. So then let's find the number of n reachable nodes. Let's use DFS. This is the method, and for this method we will pass head and n is the number of nodes, and the graph. And at last, we need to print this number. Now let's try to implement this DFS method. Its parameter is, first is the head, then its number of nodes, last is the graph. First, we'll need a visited array. And there will be n plus 1, because the node is from 1 to n. Then for the stack, we will use linked list. First, we will add head to the stack. So it's push. And visited head. We set visited head to true. Now let's try to traverse the graph stack. If it's not empty, while it's not empty, and we will we will check the first element in the stack. We will get all the we will get all the adjacent nodes, the neighbor nodes of this current node. So we will use graph get this list is the neighbor nodes. We will find from this neighbor nodes, we will find a node that's not visited, and we will put it to the stack. So let's say if the B is visited. If it's visited, then we'll continue. If it's not visited, we will put B to the stack. Also, we need to check if all the neighbor nodes are visited. If that's the case, we need to pop the current node from the stack. So we can use a boolean to check if all neighbor visited. So let's initialize with true, and if there's any not visited, then this will be false. So after this loop, we would check if all visited is true. If that's true, we need to pop the current element from stack. So that's the DFS. So at last, we need to find how many reachable nodes from 1 to n. So this would be n plus 1. Visited. So if it's not visited, yeah, we use a result is 0. So if there's any unvisited, we will plus. So at last we return yes. So now that's all. Let's try to run it. There's an error. Let's see. Visited. Oh, there's typo here. Visited. And here can put if absent. Oh, this is a comma. Let's run it again. Oh, there's no, let's see. Visited. Oh, here. If it's visited, we continue. If it's not visited, we'll push it, and we will set it to visited. Let's try to run it again. So yeah, now it's passed. Let's submit it. Okay, that's all in today's video. Thanks for watching. Bye bye.